Conditional probability talks about a probability calculation, but we're given some extra information. There's something else going on that we're made aware of. This extra information usually eliminates some of the possibilities. So an example of that is if I have to make a probability that the temperature is above 35 degrees, then I have to consider every single day out of 365 days in a year, for example, and then there'll be a few days, let's say there's 7 days that are above 35, then my probability that the temperature is above 35, oops, I can't even write a 5 there, let's try now, will equal 7 over 35, so also over 365. And that is a standard probability calculation. But if I get into conditional probability, I might ask for the probability that the temperature is above 35 given, and that's the sign for given, and that's a key word for conditional probability. And look, there it is already there. What an amazing coincidence. Given that the temperature was above 20 degrees. So what happens now is I've effectively eliminated the possibilities that the temperature was below 20 degrees. So here this is just the probability my temperature was above 35 degrees on any given day in a year. Whereas this circumstance talks about the temperature being above 35 degrees, given that the temperature was already above 20 degrees. Now, my formula for this will be, you'll be given a formula, but let's have a look at what this means. If I had my 7 days where the temperature was above 35 degrees, and in the year there were 83 days where the temperature was above 20 degrees, then the probability that my temperature is above 35 degrees given it's above 20 will be temperature above 35 given the temperature is above 20 will be 7 out of 83. We've eliminated the possibilities when the temperature was below 20 degrees. So that's how that works. Now the formula we use says that the probability of A occurring given B has occurred or B occurs is the probability of A intersecting B over the probability of B. So in this example, if I was going to put down, or I was going to enter this information into this formula, A, and it's always wise to make a note of what A and B are. So A here would be temperature above 35, and B is the temperature above 20. So therefore, the probability, or A above B, so the probability of A and B both occurring, that's the intersection, means the temperature is over 20 degrees and it's over 35 degrees. And that might sound a little bit confusing, but let's have a quick look at a number line. If here's my temperature number line, and here is 20 degrees, and here is 35 degrees. Let's just get that right, 35 degrees. Then my temperature being above 20 degrees looks like that. My temperature being above 35 looks like that. They both exist where the temperature is above 35. So my probability of A and B both happening at the same time is where the probability is the temperature above 35 degrees. And the probability of the temperature above 20 we've already calculated. Then what I would do is put these into the formula. So to do that, I would say my probability that the temperature is above 35 given the temperature is above 20. Given the information we had before was the probability the temperature is above 35 is 7 days out of 365. Over the probability the temperature was over 20, we had 83 days over 365. And now what I have to do is I have to manipulate these fractions. Now, whenever I see a fraction over a fraction, I get a little bit nervous, but remember to tip and times. So if I'm dividing by 83 over 365, I can do 1 over that and multiply. So that's the same as 7 over 365. Or if I want to, let's go even step by step, divided by 83 over 365. I'm doing exactly the same. I've just changed the way it's written. I tip and times. That's 7 over 365 times 365 over 83. And then I get out my magic cancelling pencil and I see that I've got a whole lot of 365s here. So that disappears and that disappears. And I end up with 7 over 83 as my probability. And there's a tick and a glorious smile from the examiner or your teacher. And that's how we manage a calculation with conditional probability, understanding that the key word for a conditional probability is given, and the key technique is using the formula and defining what our A and our B are. Now there's an example ready for you to do, so please go to your books and do that example now. If you found this video helpful, please like the video, or even better, subscribe to my channel. Thanks.